In lesson 10, we had a look at translations of f of x with vertical and horizontal translations. In this next lesson, lesson 11, we're having a look at dilations. And dilation is the mathematical word for stretching. So if we are stretching our function, it's called a dilation. We can stretch it in two directions, just like we can translate it in two directions, either vertically or horizontally. Before we go any further though, can you please make sure that you've done the graphics calculator investigation on page 82 and that you've written your observations down in your book. And one more small thing, in these two little boxes here, I've already changed the bottom one, you've got c is greater than 0 and k is greater than 0. It should be c is greater than 1 and k is greater than 1. So can you please make that change? The dilation factor will do different things depending on where it is in relation to the function. In this original example that we've got here, the dilation factor is outside of the function, and what it's doing is it's multiplying the entire function. If c is greater than 1, so for example 1.5, 2, 10, anything like that, what happens is the function is vertically stretched, so it's dilated in a vertical direction. And whatever c is, it's dilated, stretched by that factor. If c is between 0 and 1, so 0.1, a half, 0.9, the function is vertically compressed by a scale factor of c. In the second dilation factor, or second location that the dilation factor can be in, if it's actually multiplying each individual x, and not the entire function, but each individual x, as in f of kx, then k will horizontally dilate this, by a scale factor of not k, but 1 on k. And again, there's a difference between k being greater than 1. If k is greater than 1, instinctively you would think if k is greater than 1, it's going to stretch it. But in actual fact, when k is greater than 1, it compresses it. It compresses it by a scale factor of 1 on k. So if it's f of 2x, then that function is actually going to be half as long as it was when it was just f of x. If k is between 0 and 1, so 0.1, a half, 9/10, then that's when the function is stretched. So there's actually an inverse relationship between k and the length of the function across the domain. Something for you to have a think about and to jot down in your notebooks is what happens if c or k are negative. In the next video, we'll have a look at what happens, or I'll mention what happens when c or k are negative, and we'll have a look at what c and k actually do on the graph.